Hi everyone, and thanks for coming. On behalf of Quantox Technology, I would like to welcome Ida and NEAR Balkans team here to tell us more about developing on NEAR blockchain. And I would like to ask Ida to say a couple of words about what are we going to do here today. Welcome.
Thank you very much. Hi everybody, good day. It's already a bit later in the afternoon, but we're gonna try to make it like very interactive and practical, so hopefully keeping you awake for the next 2.5 to 3 hours. My name is Ida Pandur. I am CEO of NEAR Balkans, which is a regional hub for NEAR protocol, which is L1, layer 1 blockchain. With me, I have Andrej, who is coming from one of the dev shop partners. 4.0, we've been working together on multiple projects, so he has like a really good practical experience of working on NEAR blockchain developing, but also as a partner and collaborator with NEAR, so you can get like a first-hand experience from one colleague to another. And Alen, who is our tech lead at NEAR Balkans, who is also overseeing and developing products within the NEAR Balkans. I will just tell you briefly in 3 to 5 minutes a bit more about us for those of you who don't know, so you just know like what can you count on us for. And then I'm gonna let you to the guys to actually dive into the topic itself. So before we start, I just wanted to ask you how many of you have been doing any sort of development work in Web3, if you can raise your hands. Okay, so we are like perfectly now at the beginning of your journey. So welcome to your journey to Web3. We are really happy and honored to be the ones who will be enabling this. Quickly about NEAR Balkans, we have started our operations in the region 1st of April 2022, so we've been present around the region throughout the last 1.5 years. There are many other blockchains who are present in the region, such as like Polygon, Sui, ICP, Solana was here also, we see the logo. Essentially, a lot of projects, a lot of serious players have seen that within our region there is not just a huge, amazing Web2 IT talent, but there is also great Web3 talent. And this is why more and more of them and more of us are starting to build a serious presence. Why is this important? This is important because we are now on the beginning of the next cycle. There are market cycles that are changing every like 3 to 4 years. We've been through the last 2 years of the cycle being down, like bear market, everything is bad, crypto is dead, all these kind of stories. Now we started recovering, which essentially means that in the next year we can expect a huge inflow of interest into blockchain projects, which means, translated for all of us, that there will be a lot of business opportunities, a lot of opportunities to work for the clients, to develop for the clients. So one of our roles in NEAR Balkans, like the other chains, is that because we are some sort of the bridge between our region and the big protocols, our main role is to be here to educate. So to provide you necessary resources to onboard you a bit more into the developer/founding journey of the Web3. And after that, once you start developing for the clients, or you guys decide, okay, we want to develop some of our products, to be here as a support, because it's much easier to call me or Alen or Andrej or anybody within our region than trying to reach somebody in the United States or Switzerland, etc. That's why we are here, we are present in the region, and like you can get us easily in our own language and we can make the stuff happen. So that's the whole point. I want to thank Ivan and the team for organizing this. I really hope that this will be very interesting to you. If there is, because we are at the beginning and the introduction, the way how the workshop is structured, guys will tell a bit more, but NEAR has this specific thing where if you know JavaScript, TypeScript, you can like easily start developing in Web3. That's why we think that for most of you who are front-end developers as well, this should be quite an easy thing to do. So, but without further ado, Anything that is unclear or something, just ask us, let us know, give us comments, and let's make this workshop nice and successful. And thank you very much for coming here. Thanks. And now I'm giving the word to Andrej to kick off the workshop itself.
Hello everyone, my name is Andrej Šarić. I'm just going to kind of about myself so you can get an idea of who am I and what am I doing here and what I'm talking about these things in general. So I've been a software developer for the last 12 years. I started out at Java at the college and stuff like that. Quickly moved on to Objective-C because I'm an Apple fanboy basically, so I wanted to do some iOS apps. Also did Android development, still in Java. There wasn't an Android Studio back in the day. We were using Flipsmith plugin to do Android development. It was a long time ago. Aside from that, I did a lot of front-end development. Started with Angular from the alpha, then the beta version of Angular. That was a really difficult transition back in the day. Did a lot of backend development as well, mostly with ASP.NET, C# basically, and the framework stuff like that. Node.js and Nest.js lately. So nowadays my stack is basically Nest.js for the backend stuff, Next.js for the frontend stuff. And when it comes to the UI frameworks, I don't know, my choice would be Mantine, for example. I worked with Material UI and other frameworks as well, but currently I find myself using Mantine or Tailwind CSS just usually. So I was doing a lot of Web2 development before I transitioned to Web3. I did basically a lot of stuff from front-end, back-end, databases. I was also teaching at the college, American college in Croatia for 6 years, where I taught like relational databases, non-relational databases, web development, mobile development. I also did robotics at one point in time, a lot of stuff with IoT because my previous company, we built a lot of smart city projects specifically for the city of Dubrovnik, for example, in Croatia. And eventually, like 2 years ago, I kind of like burned out. I was like sick and tired of everything. I quit everything, left that company, left it to my partners, told them like, take the money, take the clients, this is it, this is my obituary, I'm dead for you guys. Stopped teaching at the college, and I just went to relax for a while. I got like maybe like 2 or 3 months of relaxation, and then these guys from Web3 basically kind of pulled me in. They just like, come, let's do something cool. And I ended up in Web3. Even though that was not my first experience with Web3, my first experience with Web3 was actually back in 2016, so beginning of 2015, beginning of 2016. Right around the Ethereum's ICO, I would say, maybe a bit after that. I remember that the price of Ethereum back then was $1.15 or something. It was ridiculous. And I specifically remember all of that because I was working on a project for a client in Miami, and they had to pay me around like $12,000 or something like that. And this guy comes in and offers me like, how about I give you like 10,000 Ethereum instead of $12,000? And I was like, no, I'm good. I don't want this magic money. Like I'm not gonna do that. Like, just give me cash. I want like, give me dollars, give me euros, give me kunas, give me whatever. Just don't give me like magic money like Bitcoins and Ethereum. This guy actually tried to get me to take Ethereum for like 2 weeks, but I was adamant. No, I'm not taking any Ethereum, and I did not take any Ethereum. So 10,000 Ethereum down the drain. Yeah, I hate my life. Yeah. So yeah, but if I took them, who knows? I would probably not be here today.
You would be on your yacht.
Or dead. There's like 50-50 chance. So yeah, that was my first experience with Web3. I got kind of into it when I declined all of that Ethereum. I was like, yes, I'm an idiot. I'm a huge idiot. I started investing a bit. I started looking at the development as well. Solidity was just kind of like picking up and so on. But there was not a lot of a community back then. Like, there was not a lot of community in Web3. There was not a lot of tutorials. There was not a lot of documentation. And I was like, I don't know about this. Like, this may or may not be a long-term thing. So do I want to invest my time into this right now? So I decided against it. But when I got called back to Web3 almost 2 years ago, the first thing that everyone presented to me was NEAR. I was like, okay, NEAR, like why is this thing interesting? Is it just another layer 1? And then I took a look at NEAR, and actually it was amazing. First thing that got me was actually, they actually had developer documentation. They actually had examples. They actually had a community. They actually had something called office hours, where you could actually connect with their engineers on a daily basis and actually talk to them, ask them questions. And I was like, okay, this actually now makes sense. Now I can actually build something on this thing, and if I get stuck, I can ask someone for help, right? So that's how I started with NEAR. And NEAR is actually just one of the chains that I'm working on, but definitely the one that I come back very often to. So yeah, this is just kind of like to give you an idea of what I did. And after all of this, if you have any questions about any of the things that I mentioned in all of this, from IoT to robotics to Web3 to whatever, I will try to answer those questions. Well, yeah. So we can skip this. So basically the agenda for today. So we'll start off with a bit of theory, right? I actually hate theory. I actually hate presentations as well. This presentation was given to me, which is beautiful. It's beautiful. So I'm going to kind of like breeze through it. I do like actually taking things like doing practical things. I feel that's how we learn. And as I'm talking about a bunch of stuff, I'll be exiting the presentation. I'll be opening all kinds of links to just kind of give you an idea where you can find these things that I'm talking about, right? Because no one is going to open up a presentation later on at home. It will be much easier if you know where to find what. So we will just talk a bit about blockchain, what blockchain is. We'll talk about NEAR, OpenWeb, and the wallets. And then we'll talk about smart contracts. We will build a smart contract. It's going to be a simple smart contract, nothing too crazy. We will build it using TypeScript, which is a familiar language probably for everyone here. And finally, we'll have this deployment of a decentralized front end. Once again, everything's going to be done in a kind of like a React-like way. So it's really not that difficult. Duration is 3 hours, which is very optimistic. We're not going to be here for 3 hours because I'm going to die. Blockchain basics. I mean, blockchain is a difficult topic. Anyone who tells you like they can easily explain the blockchain to you, they are lying. Yes, they can explain the concept of blockchain, but the easiest way to explain it, basically, like to dumb it down, is blockchain is a database, right? Blockchain is a database. This is where you store some data. How it works? It works, has a bunch of blocks. Blocks come in, transactions come in, you're writing something. Just imagine you're writing something into the database. Every time you write something into the database, you create a new block. These blocks are chained together based on some hashes and some cryptography. And what you get in the end is a chain of blocks where you can always verify that the information is truthful and correct and that everything is fine. A very, very simple thing. Advantages of the blockchain, well, yeah, the transparency, being able to verify stuff on it and data from it. The disadvantages are usually the cost of writing to the blockchain, the speed of writing something to the blockchain, and having enough validators actually to make it truthful. So how many people here actually know what blockchain is? Like how no one, right? Like 1, 2, yeah. So let's try to I will try to simplify it a bit more. So when you have a regular database, MySQL, Mongo, whatever, like relational, non-relational, it's completely irrelevant. You have a database. You have a centralized place where you keep all of your data, right? Well, of course, you can also shard the database, and then you can have multiple replicas of it, and so on and so on. Let's just imagine you have a single database. The usual problem that we have, which like blockchain solves, is the fact that if I have all of our data in the database, and let's say we have transactions about sending money from one another, and I have a transaction where I'm sending Alen is sending me $10 US, right? Nothing is stopping me from coming into the centralized database and changing the amount from 10 to 100. Basically scamming him and saying, no, this was $100 US that you sent me, not $10 US. Now, this is where blockchain comes in. In blockchain, you don't have this one centralized entity. You don't have this one board where you can come in and change something on it. Every single person in this room would have their own database, their own board, for example. And in that case, we would all be called something validators. So we would be the ones validating the data that is coming in onto the chain. Now, why do we want to do this? So why would I be one of these so-called validators? Why would I run something on my laptop the entire time to check the validity of everything that we are writing into the database? Well, the first thing is, well, that's how the blockchain runs. So if we have this situation where Alen sent me $10 and I want to change that information, and I just change it in my copy of the database. If it was a centralized database, yeah, I would be scamming Alen. Like, he doesn't have a copy, he doesn't know what's happening, I'm in full control. Just like Apple, Google, and all of the big players are currently in full control, right? But if this was blockchain, every single person in this room would have a copy of this database, right? And when I come in and try to play smart, oh, you did not send me $10, you sent me $100, all of you would rise up and say, no, 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 you're lying, right? We all have copies of this database, we know that you're lying, you just change it in your thing. And then you would just push me out, basically. So this is kind of like a simplified way how blockchain works. I already talked about advantages and disadvantages. Basically, advantages, the transparency, everyone sees what's happening. We can verify the truthfulness of transactions of the data. Disadvantages, well, it's costly and it's transactions can be slow and it can be costly to write data on it. Just to jump back to the validator part, why would everyone here run their own, have a copy of the chain on their machines? It's usually because you're doing you're a validator, so you're doing some mining or proof of work, proof of stake, or whichever consensus is being used. You would probably get rewards. You would get some rewards for doing that work, for verifying all of these transactions. So you would be making some money. Back in the day, a lot more than nowadays. I kind of already talked about this. So blockchain, it's just kind of like a lot of blocks. Every block has, so we have a hash, a data, payload, which we're saving into that block, and we have previous hash. So the way we check that everything is correct is based on hashes. Any small change will also change the hash, which is very simple to understand. As we are doing transactions, these blocks are growing. Depending on the blockchain, these blocks will have different times to finality before they are actually approved, verified, and actually published completely to all of the actors in the ecosystem, right? For example, on NEAR, I do believe that the time to finality, like once I do the transaction, once I submit the transaction, once I do some action, I want to write something on chain, I think it takes kind of approximately between 1.3 seconds to get to the time to finality for the actual action to be written on chain, which is actually really, really fast. Okay, we had actually slides for all of these things. We could have told me something about this. So, okay, yeah, advantages, like decentralization, that's what I kind of like, when I explain everything, where you would call me out that I'm lying because everyone had a copy of this database. It's not on my server and I'm the only one in control. Everyone has their own copy. If they're validators, security, once again, the way that I played around before, I tried to scam him. We have the security because you would call me out. No, you're lying. He did not send you that much. And transparency because everyone can check what's actually being sent back and forth from which addresses. Okay, yeah. So this is actually a very, very good slide. This comparison between Web2, Web3. Web2 is what we've been doing up until now, let's say. Web3 is just this transition from having all of these centralized things and going into the decentralized way of doing stuff. Like, okay, I think the first one is kind of weird, like Chrome, Brave. Yeah, Chrome, Google Chrome, like the most popular browser almost out there. Brave is kind of like an equivalent in Web3 world. It doesn't really have to do with anything but the fact that Brave really has good integrations for the wallets. It already comes with a wallet for certain chains, which is really, really good. GoDaddy, so the main names we have on Ethereum, ENS, where instead of having this address of your own, like when you create a wallet and everything, which we'll see later on, in most of the EVM-based chains, your address is going to have a bunch of characters, and it's very, very, very difficult to like memorize it. You will not memorize it probably, right? ENS is just having your own domain. For me, having my domain instead of having this wallet, which is x0 a bunch of characters, it would be Andrej.th or whatever. Spotify audios, there is a lot more, there is many more platforms for music streaming. This is becoming a really, really cool thing. I just actually worked, we just finished up a project last month that's actually also a music platform. It's a really, really cool industry. Basically, with these music platforms, what you can achieve with the decentralization and everything is you could avoid actually having record labels in the story. Basically giving artists do not have to give money to the record labels and pay royalties and stuff like that. So that's actually really cool. Okay, YouTube and Odyssey, it basically was the same thing. Dropbox and Filecoin, that one is actually interesting. I do love Filecoin. Filecoin is one of the projects for the file storage. So currently, when we look at the Web2 stuff, so we have Dropbox. You will go on to the Dropbox, or you go to Google Drive, right? You will upload your files there. All of your files are stored on centralized servers, right? So what happens if Google shuts down? What happens if Dropbox shuts down? They'll probably notify you, we are shutting down. You have like 30 days to download all your files. Or if something even worse happens, like Swan event, you won't even have time to recover your files. They're just going to be gone, right? So Filecoin and other projects like Filecoin, SiaCoin, I think those two are the first ones that pop in my head. They do this decentralized file storage, basically. So I want to save a file. I will pay with some token to save my file. I will upload it to whatever UI. And the cool thing is, let's once again imagine you're all validators here. Everyone is running a copy of Filecoin instance, node. I save the file. This file is going to be saved on multiple machines. So you're going to be earning money for keeping my files. They're going to be encrypted. You won't be able to access my files, of course. You won't be able to see what I uploaded. But you'll be making money because I'm using your storage from your machine. And you're keeping my files safe. So even if a couple of you stop running this node, if you stop running the server, let's say, my files are still safe because there is at least someone else who is running it, right? As long as it doesn't happen that everyone shuts down, then, well. So yeah, file storage is actually a really, really cool thing, and there are some cool projects in this industry. Okay, WhatsApp status, there is multiple other as well projects that do like messaging and so on, but messaging is a bit more difficult to build in Web3 because of the transparency and everything. So, but yeah, status is okay. And who else has it recently? I think ConnectKit from Web3 ConnectKit is doing something with for messaging as well. Okay, Facebook District, yeah, District, it's kind of an older one. Lens is another social network. This was a very, very big thing back in the day to build social networks on Web3. Even nowadays, one bigger thing in Web3 is when it comes to these social networks and social stuff, is actually doing this social reputation thingy where you build your own reputation online through these decentralized products. So basically, you would have your own profile. You would earn your reputation, and based on your reputation, you would be able to do certain actions or access other decentralized apps, which is really, really cool. Okay, Google pre-search, nothing much to say there. But PayPal, MetaMask is a wallet. PayPal, well, used for money transactions. MetaMask can also be used to send tokens to one another, but it has even more usages than just that, from signing transactions, interacting with apps, and nowadays with MetaMask extensions, it's even more powerful. But back to NEAR, okay. So Sharded layer 1 blockchain. Layer 1 blockchain just meaning that, well, they're layer 1 blockchain, they are not dependent on anyone else. And this thing sharded actually plays a huge role here, because NEAR started off and built something really, really cool. They built a sharding mechanism, Nightshade, and a technology called Doomslug, and they basically have these shards.
that allow them to increase the throughput and the number of transactions. So when you guys want to have a copy of the NEAR chain, you want to run a node and everything, you will become a part of the shard. And these shards, I do believe, now I don't want to take my word for it, but I think they had around 20 seats in it. So the idea is, so when in one of these shards, I go into the shard, you go into the shard, you go into the shard, and as more people are coming into the shard, up to 20, you're receiving rewards. The more people come and start validating the transactions, the rewards will become lower, thus incentivizing people to go and open up new shards. Okay, so that's the entire idea. So we all want to be a part of this. We want to be validators. We want to validate some data, but we also want to get some rewards for it. So NEAR actually approaches with this sharding system, which is actually proving to be actually really, really good. You will find like basically two schools of thought here. Sharding is amazing to increase the throughput, to increase the number of transactions, but at the same time, it's very, very difficult to keep the consistency between the shards. And as well doing some cross-shard communication and stuff like that. So it's kind of like a very advanced topic, but you can find a lot of stuff about it online. Iliad, one of the creators of NEAR, actually has a lot of these whiteboard series about sharding and the way they implemented it. So yeah, NEAR protocol. Yes, I'm moving to the next slide. Okay, scalability, security, accessibility, scalability to the sharding, security, using blockchain technology and accessibility. This is the one that I like, is because it's really accessible. It's easy for people to get onboarded onto NEAR, not just as a developer, but as a user, which you will see when we get to the part where you're going to open up a wallet. I mean, Alan's going to talk more about that, but for example, when you look at the EVM stuff, where you have Ethereum, Solana, and some other chains, you come in, you create this wallet, and you get this big line of account name with a bunch of characters. It's not really user-friendly. NEAR has approached it in a different way, where your account name becomes more user-friendly. It's much easier to do stuff there, and they really did a lot with onboarding. Usually the biggest problem that people that come into Web3 have is, oh, I created the wallet, where do I get the tokens, right? How do I start off? Like, yeah, I have a wallet, but no pesos, right? What do I do now? NEAR has a really cool onboarding solutions for this thing, where it allows you to open up a wallet and also get some tokens with the wallet, so you can actually immediately start doing some transactions. Just like some other chains, like, I mean, EVM, Biconomy, for example, Sui has it as well. These sponsor transactions where people can open up a wallet and apps can actually sponsor some of their transactions so that users don't have to spend money. Okay, advanced developing on NEAR, scalability and efficiency, once again, sharding, security, interoperability. Interoperability is actually very, very interesting. We'll talk more about interoperability later down the line when we get to this boss thingy. I'm just going to mention now, for example, NEAR is a layer 1 blockchain, right? And there is many other layer 1 blockchains. Like, one of the biggest one is probably Ethereum, EVM-based blockchains, right? So what NEAR did very, very early on is they sponsored and they allowed another company to build this cross-chain solution. It's called Aurora. Aurora is amazing. Basically allows you to do transactions from NEAR on EVM, EVM to NEAR, and do the communication, which is really, really cool. Okay, NEAR is entry point, Boss, let me just, before I go into Boss and everything, let me just talk a bit more about NEAR and the developer stuff in the NEAR's ecosystem before we jump into this. That's what's interesting for us. That's the most important thing, right? So when you want to build something in Web3, the most important thing about all of these Web3 dApps, decentralized apps, is usually a smart contract. You'll have something called a smart contract there. These smart contracts are, if you're looking at the EVM ecosystem, then you will write them using Solidity programming language, which is actually not bad. You also have Viper in some other languages. On some other protocols, you will use Rust. On Sui, you will use Move. But on NEAR, you will actually use Rust or JavaScript/TypeScript, basically, which is really, really cool. So I can come in. I don't have to learn a new programming language to write a simple smart contract or any kind of smart contract on NEAR. I can just come in with my knowledge of TypeScript or JavaScript, and I can write my own smart contract. I'll talk more about that SDK later on. From writing smart contracts, which is very, very simple on NEAR, to being able to run your own indexers and stuff like that, everything is really, really easy to set up, which is really, really cool. Boss is actually kind of like new product. I think it's been around for a year. Maybe, has it been a year?
Something like that.
Yeah, I think around a year. Blockchain operating system. Do you have it in the slides? Yes. Blockchain operating system. Now, there was a lot of hype when this came out. Like, what is this thing? Like, what is a blockchain operating system? And I honestly like the concept of it. I love the concept. Basically, the idea of the BOSS, blockchain operating system, is that you can create UI components that are decentralized. So, anyone here works with React? React? Yes, we have a lot of React. Everyone is doing React, of course. So in React, what we have components, right? You will probably do some, we'll create some components, then you will basically compose and nest those components within the other components. And this is kind of like what BOSS does as well. So your dApps, your whatever you do on it is going to be a component at one point. So you will build a component in UI, you'll be able to nest that component to another component, and you can build the entire UIs around this thing. The cool thing is that once you write the code for your component, which is very, very similar to React, you have the state, you have everything. The cool thing is that that component will be saved on chain. And it's actually then later on being read from chain and being served in the browser. Now this part, where we get to the browser, is not so decentralized because there is a server that's rendering with the virtual machine and everything, these components, but the code itself is actually decentralized because it's stored on chain, which is really, really cool. Another thing there is, well, it mentions here NEAR and Ethereum, which are two different chains. It allows you to do a lot of interchain communication, basically. And it's very composable in school. We're going to show you a couple of examples of it later. And yeah, I got this part you can take now because my throat is. Yeah.
Thank you very much. Hi, my name is Alen. I'm a senior software developer with 8 years of experience in Web2 and then a year and something small in Web3. I have joined NEAR at the end of last year, and I've been working on the projects and educating the people about the blockchain, Web3, and protocols, and what the people can do with it. So for today, what I would like to do is I would like to give you the definition and purpose of crypto wallet. What is it used for? How is it used? And then we are going to do it the practical part of the workshop. We are going to open the NEAR wallet, and then we are going to see the smart contract and publish our first component actually on the blockchain operating system. So, what is a wallet? Wallet is actually a tool that does anybody knows what is a wallet? Okay. So wallet is a tool that enables you to interact with blockchain protocols and their functionalities and applications. So what is wallet based from? It is based on public and private keys. So this is like an old way of cryptography, which is here from 1950s, which says that there is asymmetric encryption between two people. For example, if I want to send to Andrej or to somebody, I want to send something that needs to be decrypted only by that person, I am going to encrypt the file or transaction or message with the public key of that person, so that only that person can actually decrypt it with his own private key. So, and this is actually done in all the protocols. This is the same base of communication and functionalities in all protocols. When you create a wallet, you get your public key pair, actually, public key pair. Private key you are storing in your wallet, private key you are storing in your wallet, public key you are sending out to the grid so that they can actually verify that it's you, the transaction, if you're signing something or if you're encrypting, so that actually they know that that came from you and that you actually send it. So, just a second. Yeah, so we have 3 wallet types. We have hardware, software, and paper. For example, MetaMask that was mentioned earlier in this conversation was software wallet, which is actually in the computer. And then, what does that mean? It means that it's stored on your device or local storage or somewhere third. And with that, you can actually use it to authenticate yourself with the applications, to send transactions, to send tokens to another wallets, and stuff like that. Then we have extra layer of security, which is hardware wallet, because you can lose your device, you can actually, I don't know, somebody can steal it, or you go to the bathroom and somebody goes there and then it just flops your wallet. Which means that with hardware wallets, those are like digital.
Actually, I think I have mine here.
So it's like paper, but futuristic. Okay, so this is,
small device. You connect the cable to it.
Yeah, the computer reads it, and then you have your own, this is the storage for your private key, which means that it's not on your device, it's your physical device, on your physical device that is USB in general, that actually then you need to sign in, log in, and authenticate it so that you can send the transaction. This is like an additional layer of security. And then there is hardcore paper wallets, which is actually, just write private keys and public keys on paper or generate the QR code that actually does that. And then, this is like cold storage, let's say it like that. Okay, so this is for the theory part. Here you can actually scan and join our channel for dev support for future. And what I would like to do now is to send you an email, which you're going to get with the link of on which you will be able to create a wallet. I will try to do it with you. Okay, it's 1 minute delay, so if your email was on this participant list, you should get the...
Yeah, it was sent.
Okay. You should get the email with the link that you can press, and then... So we remember that it would be cool to do it, together. So we are waiting for one link. So this feature is actually when you want to create a wallet with seamless user experience, and then NEAR has actually this thing that is called keep on, which actually says, okay, listen, I have a wallet, I want to create 100 new wallets with 100 with each wallet that has 1 NEAR token, and then it just generates the links, and then it is okay. Wait, sorry, posla. And then you just follow the steps. Okay, so did you receive the email? Okay, give it a second. When you click on the link, this is the page that you should see. I sad kad otvorite, tamo bi trebalo zapravo biti taj email, imate link koji tiđete, bit će popis ljudi koji su prijavljeni na radionicu i pored njih će biti, svako će imati svoj link. Samo reci, just let me know when you go to this page. Okay. Can we move on? Not yet? Okay. Did everybody receive the mail? No, not yet. You didn't receive the mail. What is your email?
Čekaj, samo snimam ekrana u ponuditi.
Može, ali with X? Aleksandar, KS ili X? KS.
Ovdje ima 88 Popović.
@gmail.com? Quantox. Aha, ok, so ko još nije dobio? 1, 2, 3, 4, svi ostali jesu. Samo malo. Onda ćemo to ovako. Onda ćemo... Evo da... Samo sekundu. Kak si... Andrej? Telegram? Da pokažemo ovu tablicu pa da samo skopiramo. Aha, nije paljeno bio, ok.
To će moram slučiti sam da ne dolaze poruke. To čisto da krećemo screen sharing.
A upalio si screen sharing?
Pa mislim ovaj screen recording. Koju tablicu? Drive, jel?
Da, ovo što je poslao.
Samo ko sporo sad.
12. Aha, updating.
Evo.
Okay.
You do you.
Who didn't get the email? So, what is your name? Okay, just a second. Yeah, you're not on the list.
Uzore wallet, onda break. Može. Savršeno.
Just a second. Okay, that's one. The second. Okay.
Za koliko dolazi?
That's two. I guess then all of those you're not just on the list. So 1, 2, 3, 4, right?
Taman za
Yes.
oba dijela možemo pauzu.
Okay. Aha.
Cijelinu onda pređemo drugu.
Yeah. No, okay.
Onda kao ovo završi, da ćemo pauzu, ja? No, što odluči. Je glupo da počnemo onaj drugi dio. Ne želim se puno miješati tamo. Ne želim se puno miješati, ne mogu pomoći.
Ne.
Ovo su oni Filip.
Aleksandar Popović, dobio ste, super. Ajmo zapravo onda po mailovima. To the mail. Strahinja. Ok. Milan.
Kako se radi platform?
Evo, minuta, 1 minute. Everybody else got to this page? Not this one. This one. Yes. Awesome. Okay, so just to explain this, so when you go to the link, you will be given, so you can create new wallet, or you have already your own wallet, which you can then add these funds to. So since you're creating a new wallet, once they get the email, we'll click on My NEAR Wallet, and you'll receive 0.2 NEAR for this workshop, so that you can actually deploy the boss component afterwards. Just give it a second so that everybody gets to it. Just let us know when you receive the email. Ide. Generira taman sad je posao, znači sve ok. Yeah, no, it's okay. Thank you for your patience. It's just technical part that is currently being done in the background. Ok, možemo krenuti dalje, trebali bi sad dobiti svaki čas, a jako su jednostavni koraci, pa ćete samo na brzinu nastaviti. Ok, so when you get to this page, since we are creating a new wallet, you will select My NEAR Wallet. After that, you will be redirected to this page, in which you will select claim with new account, or okay, and then here, this is the advantage of NEAR, which is you get human readable name of the wallet. In general cases, there is 32 characters that is based for wallet. So here you can actually type anything. For example, my name is Alen, and then I have M, and then what my account is going to look like is going to be alenm.near. So when you decide your name, okay, then set then just a second. Because it's I'm not in incognito. Sorry. Let's do it like this. Okay, so My NEAR Wallet. Okay, yeah, of course. Claim with new account. And then, so this password is actually used so that you don't need every time you want to log in with your wallet, use the seed phrase. So this is like a handy secret password that you can have, so that you don't need to every time write 12 words that you're going to get later. So just pick any password that you want. I think it's only mandatory to have 8 characters. For example, Quantox workshop. Just okay. Then after you acknowledge, continue. Now we're getting to this to this screen. So I'm going to say Alen M. If the account is available, it should see something like this. If it's not, then it's going to be red. So just pick your account name. After you do that, reserve my account D.
Just to jump in, this is the part of the accessibility that I was talking about prior to this, where I said like NEAR is a bit more accessible to the end user than the other chains. Just because of this thing, like initially because of this thing where you can actually pick your own username instead of having this 3264 character account name, which is ridiculous.
Exactly. So now here we are on security method, which is actually secure passphrase, which are 12 words, which is seed phrase with which you can actually unlock your account. Or if you have a ledger like Andrej has, then you will connect to it with this. So we are going to select secure passphrase. Okay, so this is the most important part. So this is the key to your wallet. You cannot, if you lose this, you're going to lose your wallet. So screenshot it, save it, and just copy it, for example, and place it somewhere safe for now on your laptop. After you get home, just write it down on a piece of paper and put it somewhere somewhere that nobody knows, and that should actually do it. So, imaš neki notebook, tako nešto sam da zapišem sa strane.
Čekaj, neću još malo to otvoriti ovdje.
A samo otvori novi ovaj. Novi ovaj. Control, ne. Evo. Okay. So now when you see these are 12 human words which are actually, readable. So when you continue, it's going to ask to verify the phrase, and it's going to give you the random word from that seed phrase. First phrase here is armor. So when I go here, I write armor, verify and complete. Okay, so you get this message, your NEAR drop has been claimed, everybody should get 0.2 NEAR. After that, we are on the wallet account page, which is the page for the activity for what you can do with your account. On the right upper corner, you see your account name, and then you have this hero header, which is wallet, staking, explore, account, and support. So in wallet, you see this page. You see this page in which is the summary of your current balance, NEAR, and then you have send, receive, top up, and swap. So when you want to send somebody NEAR, you click send. When you receive, it generates the QR code for your account. And
Sorry, can you repeat the part?
yeah. Okay. Yeah. So this is the main screen of your wallet, which means that every action that you can take with your wallet from here is here, which means that it is separated in a couple of functions, a couple of big functions, and then broken down into multiple lesser functions. For example, when you're on the wallet screen, you have here send, which is to send funds, receive, to receive funds, top up is to add funds to the wallet, and swap is to change the currency. Also here is if you have multiple currencies, it's going to show multiple currencies on your account. Here is the total amount you have. This is the first balances, then you have collectibles. Here, if you have it, you will see your NFTs and certificates that you have here currently collected by this wallet. On the right side, you have Explore NEAR, which is like onboarding and stuff like that. And then you have recent activities, which means that here is the history of your actions that you took with this wallet. And if you go to view all, it is going to go to NEAR blocks, and then you can see everything. This is the external page that actually shows you, if it's loaded, every information that you can get for the wallet. What, sorry?
On the Explorer page, right, when you click, sometimes it can happen because of the IP.
Where? What?
So
Which one? This view all?
when you
Click
view
view
all,
all. Click view all.
Uh-huh. This one crashed.
Yes.
It
Crashes sometimes because of the IP. It happens to me as well. So
Okay. But
but
yeah.
this is the external service.
Yeah, exactly. So this is external. This is not connected directly to the account. This is just for the monitoring. What? Sorry?
Yeah,
Yes. Yeah. Okay. Then if you go to staking here, since NEAR is proof of stake, you can actually, please load. You can actually stake your tokens on the validators so that and then get the interest back. So you are saying, okay, I'm going to give you this, then we're going to stake it together, and then I'm going to get some kind of percentage of the reward.
Do you know what staking means? Like, is this term like familiar to you? If not, just raise your hand so we can explain it a bit. Okay. Yeah, let's explain it.
Okay, so there is a couple of consensus that blockchain protocols use. We have proof of work, proof of stake, and then there are a couple of that are specific to its own protocol. So blockchain, Bitcoin went with proof of work, which means that you are going to do some work, and then you're going to, and that is the proof that the blocks are validated in the blockchain. So
And you do the work through mining.
mining,
And
yeah.
this is where the whole story about blockchain is not ecological enough and stuff like that are coming from.
Yeah, because you have a lot of power that needs to be consumed to actually do the work. And then what NEAR came up with, what NEAR embraced was proof of stake, which means that you are staking your money on saying that I'm going to do the
Tokens.
tokens, yeah. Your tokens, I'm going to say, I'm going to do this validation, and I say that this is right. And then, if you're right, then you get the reward for it. If you're wrong, and somebody says, okay, you're wrong, then you lose all of the stake that you actually entered in. This is like general,
Yes,
basic.
Proof of stake is more advanced consensus way of validating the information on the blockchain, and it requires for you to put your tokens in order to validate the information. It's done through the validators, they're getting the reward, and you as a user who is taking your tokens for the validation of information are also getting the reward. Essentially, it means, to put it very lightly, it's like you go to the bank and say, I'm going to put my money on this, or you put it on the gambling.
Yeah.
Put my money on this, and if it's correct, I'm going to get something in return. This is essentially what you're doing with proof of stake.
So we're basically gambling, right?
You're not gambling. It's not like something that you can easily lose, because you're just staking, and it's just like using your tokens to validate the information. So there is not a big possibility that something will happen or you will lose. Like, you essentially put it in the pool, in the validator's pool. They use your tokens to stake, that are staked, to validate the information. And for that, you are getting a reward. And it's like from 4 to 10% usually.
Yeah, but
which means
also I can also lose all of that, right?
If the validator has been thinking
something
dirty,
goes wrong with the
yeah.
validator.
If someone comes and takes the tokens from the pool and runs away,
Yeah, if
like
they
there is no other way to
For
lose the
example,
tokens.
take the validator,
yeah.
whatever. But essentially.
Yeah, like we said, like the whole point of staking is each validator needs to stake an amount of money that if he tries to be malicious,
Exactly, he's going to get punished.
he will be getting exactly. So it's just like your stake is there for when you do something wrong, we're gonna cut your stake.
Exactly, exactly. So it's not like gambling, it's like investing in stock, something like that. And then if the stock is good, if the stock is great, everybody's going to get a cut. If the stock fails, then you're not going to get anything. Even, actually, not even, yeah, something like in general.
You're getting paid interest rates for helping the information to go through.
Actually, I like savings.
The more validators are there and the more
Like
stake
savings.
tokens are there, the
Like
more
savings.
decentralized network is,
If the bank falls down,
faster
then
the network is,
but it's very true.
and the better the performance of the network. That's why in blockchains there is a huge tendency to have as many validators because then it's more decentralized and it also shows the health of the ecosystem itself.
I mean, I don't know how to say it in English, but
Yeah.
because if you go to the bank, can you oročite novce?
Kao oročena štednja. Deposit. Yeah, that's it. If the bank fails, you're going to lose your money. Yeah, if the bank goes bankrupt, or something like that. Aha, može. Da. Probaj pa ako dođeš ovo tu inače, ako je iskorišteno, onda... A vi ste dobili? Super. Odlično. It's English creation, sorry. Okay, so this is the page that in which you can actually stake your tokens and get it back, help the community with validating the blockchain and blocks, and yeah.
And just one thing, like we are fully aware there is a lot of terminology in Web3 that can be a bit tricky. So if there is any word that you are not quite certain what it means, just ask and let's
Exactly. Okay, then we have Explore, which is the applications, projects, and everything currently done on NFTs. Account page, which gets the summary, and then you can enable ledger if you buy the ledger or you want to add this account to the ledger, you can enable it. Password.
These are like additional security.
Security, yeah, exactly. And then we have password protection, which is the first password that you were asked when you were trying to create the account, and seed phrase, which are those 12 words that are actually used for the authentication of the wallet. Export local private key, I wouldn't suggest it, but you have this option. And then you have remove account from the wallet, which means that you're going to remove the account from the wallet itself, with the key pair. Support. Yeah, this is chat. Yeah, okay, and yeah, so now you have your own first wallet.
Okay, so we're done with the wallet now. Let's continue on. We're going to take a look at the example of a smart contract. We already have a contract deployed. We will interact with it later on when we start creating this UI component and everything. But before we get to that part, I just want to go and run through the contract with you just to give you an idea of what a smart contract looks like in NEAR and in general, what a smart contract really is. So when it comes to these smart contracts, like the easiest way for a Web2 developer to kind of like get an idea what a smart contract is, I like to explain in a way that like smart contract is your backend. Just think of it as your REST API. Like a lot of people will not agree on this with me. They don't like this comparison, but I feel like it's the easiest comparison. So smart contract is nothing more than, just think of it as your backend, as your REST API. You will use it to read some data off chain, and you will also use it to write some data on chain. So that's basically what it is. Now, when it comes to developing on NEAR, the best resource, NEAR, not now, no.
Sorry.
By the way, in regards to the resources, just a digression, after the workshop, we will also share with you like post-workshop guides, so you will have the links and all the necessary materials that you can then easily access afterwards.
I'm just gonna run through, just kind of show you docs a bit and everything. So the documentation on NEAR is really, really good. Like compared to some other chains, like this documentation is really, really great. From just understanding the NEAR, the chain itself, learning more about sharding mechanism, about proof of stake and everything, to the smart contracts that we're going to talk about. And for me, which is the most important thing, we are developers, so if we don't have tooling, if we don't have enough tools to build some stuff, we're not going to build there. That's one of my first things when I pick a new technology. If I don't have the tooling that I need to build stuff, and if the tooling is not good, I'm probably not going to touch the technology. NEAR has good tooling, but like everything that you can think of, you will find it here on the docs from NEAR. from name accounts that you just created when you created the wallet, this what you created right now is called a named account. From multiple access keys, which is very, very specific for NEAR, where you can have multiple access keys using different keys for different decentralized apps, and just revoking those keys if you no longer want this app to have the ability to do some transactions and stuff like that. From the token standards, NFT standards, learning more about validators, CLI, and so on and so on. For us, the most important things are actually these two things here from the JavaScript SDK and the Rust SDK. So for writing smart contracts in NEAR, we have two options. So Rust SDK, which has been around since the beginning of NEAR. They also had an assembly script SDK, which is no longer maintained. It was discontinued in favor of JavaScript SDK. Now, even though it says here JavaScript SDK, nothing is stopping us from writing these smart contracts using TypeScript, having a bit more type safety, which is really, really good. So just take a look. So one important thing is, I'm just going to immediately mention it, as you can see here. The SDK is currently in alpha. Okay, so it's still, there's still going to be changes to this SDK, which is good because like if they just stopped at one point, it would just be stuck wherever it is. I like the fact that they did not say this is beta, this is release version. They're still saying it's alpha, even though you can build more or less whatever you want with this SDK. The full tutorial about creating a smart contract is available here on the docs. We are not going to do all of these steps. I'm just going to show you the smart contract because you have to install a lot of things from the CLI, etc. You would have to import your account so you can actually deploy the contract with your wallet from the CLI. So just like it's a long process. This is something that you can do on your own as well because you can just follow the guide and it's very simple to actually do it. So let me just jump to my favorite place when it comes to the NEAR JavaScript SDK. It's the GitHub repository, of course. Here, basically, you can find all the links to the examples, to the docs, etc. But more importantly, is where you can find examples just in a folder. So if you don't want to look through documentation, like dig through it and stuff like that, you can just go to the GitHub repository. You can find the examples. They will have a lot of examples from just the counter example in JavaScript and in TypeScript to the fungible tokens, which are actually like cryptocurrency. That's a fungible token. That's like a token that you, like ERC20 in Ethereum with fungible token. They really have a lot of examples here, and it's a good place to actually just kind of jump in and take a look. Another cool thing is that they have they're updating these benchmarks here as well, just to kind of see like how much gas, so how much additional cost is there to do a transaction on the smart contract and do something and write something to the chain, all the way to the benchmarking the size of the smart contract as well, because at one point in time, so you will build a smart contract. Once you build it, once you write the code, what you're going to do is you're going to run the command for it to build. The interesting thing about NEAR is, what I love about NEAR is the fact that smart contracts actually end up as a WASM, WebAssembly. Heard about WASM? No? WebAssembly. Well, I'm not going to really go too deep into it, but I do recommend taking a look at WebAssembly. It's not really like a new technology. It's been around for years. I do feel like it's already a game changer in certain industries, but I feel like as more people are getting onboarded and like learning about it, it's going to be even a big game changer. The WebAssembly is basically an end product of a build procedure, which takes your code and builds it as this WASM file and allows you to run this thing in a browser or anywhere else where you have this runtime, which is really cool. One of the best examples was back in the day was someone building a game in an Unreal Engine, packaging it up as a WASM and just running this game within a browser with really, really good performances. So WebAssembly is really cool. There was a lot of chains back in the day promising, we will go towards the WebAssembly. You're going to be able to build smart contracts using WebAssembly. One of the first ones that was promising that was actually EOS. I was really bullish on that one, but Unfortunately, as luck would have it, it did not really take off. Why is it so cool that NEAR is using WebAssembly? Well, it's cool because I can write contracts in Rust. So I write a smart contract in Rust, it ends up being this WebAssembly file. This later on deployed on chain, and then on chain, right? But at the same time, I can take JavaScript or TypeScript, which can also be built as a WebAssembly file, and I can deploy that thing as well on chain. So another thing is I can take another language, maybe Swift from Apple, maybe Kotlin from JetBrains, both languages that can actually be built in a WebAssembly file in the end, and I could deploy them on chain as well. So the only thing right now stopping NEAR from integrating even more programming languages that are WebAssembly compatible and allowing you to write smart contracts with those languages is just the fact that they have to sit down and write an SDK for it. So basically, they already prepared the foundation so they can enable developers to use any other programming language here that's actually has the capability of being compiled as a WebAssembly. So that's a really cool thing. I just want to kind of like mention that. So WebAssembly, not even looking at Web3, I do recommend taking a look at WebAssembly because it's a really cool tech. There are some simple examples of it online and some more advanced ones, but I do believe at one point in time it's going to become a game changer. Well, but we're still all ahead of time. So yeah, let's take a look at an example of a contract. First things first. Let's increase the size. I hate myself for this, but it is what it is. Is it visible? Can everyone read this? Yes? Oh, lovely.
Back, can you see it?
I do hope they can see it. If not, I would recommend what?
One more.
Make it bigger.
One more. Line by line.
No.
One letter per screen.
This is not clear. Yeah. If there is anyone who cannot see this at this point in time and is not wearing the glasses, I do recommend the visit to the optician or whatever, right? This point we are getting into the, oh God, this is huge. Okay, yeah. So let's take a look at the structure of the project. That's the first thing. So to build this, to create this project, we would use NEAR CLI. I already built the project here. You can ignore this AA file. This is nothing. This was just the seed phrase from the wallet from the example before. So we have a couple of things. We have the contract folder. We have integration tests. We have this NEAR dev folder. I will explain a bit more about it later on. And we have the node modules because this is we're using JavaScript SDK. Okay, here, well, git ignore is there. Not really, like, everyone knows what this is. We have a gitpod YAML, which is just if you want to run this on GitHub and gitpod and have the entire environment set up for you, you can use that. We have a script here that's actually just can be used. In fact, no, this one. This one isn't supposed to be there, so we can just ignore this one. We don't have a script. I'll probably here we have build and deploy. I will talk about that. When it comes to writing tests. That's a big thing. I know that not everyone enjoys writing tests. I do not enjoy writing tests, right? Especially on the front end. I feel like sometimes it can be a waste of time. On the back end, yes, certain services. But when it comes to smart contracts, you do want to write tests, right? So this is a thing where you really do want to write tests because once you deploy this contract is in the wild. It's kind of difficult. You can make a change to it. It's like you can make certain changes to it. You can remove it, but we are talking about people's money here. Every transaction costs something, right? Like people are sending tokens to this contract. Like tokens are being spent. So you really want to do proper testing before you let this contract go into the wild. The testing is done. I don't know if we have any tests here. Yeah, we have something here. Testing is very, very simple with Ava as a testing framework.
What you're testing here, endpoints or?
Yeah, basically,
Yes.
you can think of it as testing endpoints, basically. You're testing the behavior of the contract. So the way it works, you have these new workspaces here for JavaScript. You have the same thing for Rust. it's going to run a sandbox instance of a NEAR node on your machine. So basically what the tests are going to do is they're going to start up an entire NEAR chain on your machine as a sandbox, as a local version of the chain. And everything that you do in these tests is actually going to be kind of like committed and written on the local instance of NEAR chain on your machine. There are some other things that you can do. You could potentially also tell your test, listen, this is the block time right now, and I want you to take the state of the chain on this point for this contract and copy it into the test. So let's say I have my contract that's already live on chain, and I want to test some new behavior with the existing contract that's already live, people are using it. I could just tell the test, come on, can you just go? This is the time at which I want you to copy the state of the contract. Copy my contract from there, copy it on the local chain, and then you can run the tests on it and see what is going to be the new behavior. So the testing framework is, I mean, it's good. It's okay. It's like, it can always be better. There are some things that are missing, and everyone is aware that they are missing. Those things are being worked on, such as being able to track the events. So in smart contracts, we usually want to emit certain events. So let's say I minted an NFT. If I mint an NFT, my contract would definitely emit an event on the network, just kind of like a JSON structure that says an NFT with this ID has been minted to this wallet, right? And using these events, you could potentially have your Web2 backend track them through an indexer and then do certain actions in a Web2 world based on these events. And so this framework, for example, for testing doesn't have that support, which is a bit problematic. But there is a workaround. You could just look at the logs and then use a regular expression to extract the event from the logs, which I did a couple of times, and I did not like my life at that point in time, but it is what it is, you know. But it's being worked on. Like eventually, at one point in time, it's going to be there. Tests are very simple. I did not update the test to the current contract, but basically it would look like this. So context, accounts. Every smart contract goes to an account on NEAR. I will show you that. And then basically we're saying contract. I want to call a view method, something called a view method, which is called getGreeting, and let's check if the message that was returned is hello. Like very, very simple, like as if you were testing anything else, basically. It's not really that crazy. But yeah, tests are important. Let's just put it that way. The contract itself, that's what we are interested in. Let me close everything else, and let's take a look at it. So this is specifically now a JavaScript contract. Once again, this contract can be written in Rust as well. When we say that this JavaScript SDK is in alpha, it is in alpha, but you can do the same, more or less the same stuff that you can do with Rust as well. The only thing that I want to kind of like mention is the fact that Rust works really, really well when it comes to financial stuff, when it comes to numbers, right? JavaScript doesn't have, the numbers in JavaScript are not as precise. You have big nums and number, basically. While in Rust, you can have integers, you can have decimals, you can have floats, you can have doubles, and so on, which are more precise. So when it comes to the financial stuff, using JavaScript SDK is a bit more dangerous, okay? That's the only thing that I want to mention. When it comes to writing a contract here, we have the status message contract. So the idea of this contract is, I come in as a user, I write a message, and I want to save this message into the contract. The contract will then save my message, and when I later on ask the contract, give me my message that I wrote in, it's going to return the message. It's a very, very simple contract. There is no complications there whatsoever. The first thing that you'll see, we have a couple of imports. We can ignore the imports right now, like imports as any others. On the line 3, we have an annotation, NEAR bindgen. This NEAR bindgen annotation specifies later down the road during the build process that this class is actually a smart contract, and it should be regarded as a smart contract and built in a way, built in that way. So our smart contract is a class with an annotation NEAR bindgen. Inside of the contract itself, I have one property, so records, which is an unordered map of type string. Now, this is the first thing that we have to talk about, collections. Collections, we cannot use the regular collections that you have in JavaScript. So we have to use collections given to us by NEAR. Ordered map, unordered map, hash map, etc., etc. The only difference is this one is unordered. We have the ordered one. Some of them you can iterate over, some of them you cannot iterate over. It all depends on your use case, basically. These collections can be found. Do I have them? Let me find them here. Data storage collections. Basically, you have them here. It's a very simple thing to use. So vector, lookup set, unordered set, lookup map, unordered map, a3 map. You can see which one are iterable, where you can clear all the values from which one preserves the insertion order, and the range selection. So depending on your use case, you want to use a collection that really fits your use case. I believe we are using there an unordered set, which is iterable. You can clear the values and the range selection, even though I do feel like there maybe we could have used also the lookup set. It would be more than enough. Like we don't have to. I'm not sure if I'm iterating over it anywhere. So that just kind of like you cannot just come in and use a regular array. It has to be one of the collections that's actually supported by NEAR. So we have a property there, and then we have a constructor. When you have a constructor in a smart contract in NEAR, it's going to be called by default. So whenever we deploy this contract to the chain, the first thing that's going to happen is that this default constructor is going to be called. Whatever is here is going to be executed. In our case, it's going to create a new unordered map with a key A on chain. We have to. Now this is a weird thing a bit. So every collection that you create, it has to have its own key. So this one is A, another one would be B, another one would be C, D, E, whatever. Now just to kind of clarify this, I'm not that bad of a developer. I did not put an A here because I'm a lazy developer. I put an A here because the smaller the keys are that you're using here, the less storage you're going to take up later on chain. So it's going to be cheaper to deploy your contract. So once we deploy our contract to the chain, we're going to have to pay for the storage it's going to take up on chain. Like nothing is free in Web3 world. I want to save something on chain, be it a message, be it a smart contract, I have to pay the price. I have to pay the price for the space that I'm going to take up on chain. So using the smaller keys here is preferred. Nothing is stopping you from saying here unordered map records to actually have the key the same as the property name so you know what's happening, but doesn't really make a difference. You will never ever use this for debugging. You will never debug this thing by looking for a collection with the key A. This is just something internally that NEAR needs so it can keep this collection indexed within the chain.
Why do you need that key?
It's just
Reference to the...
it's for NEAR. It's a reference to the collection for the smart contract. So one smart contract can have multiple collections. It's basically key value storage on their side. So we have to specify key for every collection that we're going to use. If I had other collections here, like another collection, another unordered map, or another lookup map, or whatever else, I would have to give it another key than this one here. So just the way that internally the collections are being handled. So this is the default constructor. If I wanted to have a constructor that can take in some arguments up here, I would have to approach this in a different way. I would still have a constructor. I would specify what I want to pass in, and I would also have to put an annotation that this is going to be an initializer. Initialize, in fact. So that's the difference. In that case, if I have a constructor that has an annotation that it's an initializer, oh God, if I die, just leave me where I am. We have this annotation. The only difference is this default constructor is going to be called by the chain immediately. If we have our own annotation at initializer here, and if we're passing some arguments, then we have to manually, of course, call the constructor, which is kind of self-explanatory, right? Like the chain doesn't know what we want to pass in the constructor. That's basically that. Now, We have two other annotations, call and view. The easiest way to think about these ones are that call is a post method and that view is a get method. Everyone familiar with post and get? Yes? Very simple. So when we have call, we're basically doing a post request. We are going to do a change. So we're going to change something on chain. And when we have view, we are basically just reading the data. These view requests are free. Well, I lied before, so there are some things that are free in Web3. This is one of those things. If we just want to read some data, we're not going to have to pay a thing. So we can just read stuff. If we want to save stuff on chain, if we want to write something on chain, then we have to pay the price. At that point in time, we have these methods that we will actually mark as call. Now, in the documentation, you also see documentation, other people, like depending on a person and depending on what you're reading, they will either be called functions or methods. Those of you that are sticklers for the rules, these are in fact methods. They are a member of a class, they are part of a class, so they are methods, they are not functions. Functions are basically behaviors that you have outside of the class, that you have in a file and just define them as functions. So just do not be confused. If you learned that in school, do not be confused, like in college or wherever, or you learned it on your own. Do not be confused. In smart contract and NEAR, these are actually methods. Even if other people call them functions, they are not externally somewhere in a file, not a part and a member of anything. They are methods, and I will be calling them methods from now on. Another thing that you will notice, since I'm talking about these things, is that I'm using like these snake casing here, like get status, set status. I'm using the underscores as a snake casing as if I'm writing Python or Rust code. The reason for this and the reason that I'm not using camel casing here is not because I cannot. I can use camel casing, but the preferred way in the community when it comes to NEAR and JavaScript smart contracts and TypeScript in general is to use snake casing, because everything in the ecosystem came from Rust basically, and this naming convention will allow you to go through your methods more easily on the explorers and stuff like that. So we want to keep the same naming convention that we have in Rust even here. I know it looks like garbage. I don't like writing snake casing in TypeScript, but it does make a difference when someone else comes and reads your code, especially if they're coming in from Rust-based environment where they wrote smart contracts in Rust. So let's take a look at what's happening here. So the first one is call. Call method is, this one is very simple basically. We have the set status method, and it's taking in a message. So I know this is weird. One would expect that this is going to be a normal method signature where you have like message, what's wrong with me, okay? String, right? This is what we are kind of used to seeing, right? But the thing is, unfortunately, when this contract is deployed on chain, we cannot pass values to the methods in this way. So what we're actually passing, we are passing a JSON. So basically, this is the same as doing. Are you familiar with the syntax? Basically, structuring. So yeah. You just said, it's just I omitted the types here, basically. I'm not doing the full thing. So we have to do it this way because everything that's going to be passed to our methods, to our smart contract, it's going to be in a JSON format, and that's just the way the network works. Everything you send in is going to be JSON, and we have to destructure it, which could maybe be resolved on a certain layer of the chain, so we can write this in a nicer way, but it is what it is. Beggars cannot be choosers, and this is good enough, right? And it works. So let's not touch it if it works. So the first thing that I'm doing here is I'm saying let count ID equals NEAR signer account. Yes, I am aware this could be a const if someone was thinking about it. Basically, NEAR, this thing NEAR, you will not see it being initialized anywhere here. It comes from the import up there, basically kind of like context. You can think of it as contextual thing. So basically, it's going to exist when we get into the context of this method. This NEAR thingy is going to exist. I'm asking for the signer account ID. Signer account ID is just going to give me the wallet address that called this method. So you created which wallet? I don't know. Let's say I have my wallet Andrej.near, and I call this method. I'm calling this status method with my wallet Andrej.near. So in this account ID, there's going to be a value of my wallet, which is going to be Andrej.near because I called it with that wallet. That's the entire thingy here. So you can think of this in Web2 terms as if you are extracting the JVT token. Is this make sense? JVT token, we are extracting who is the user. That's exactly what I'm doing here is signer account ID, give me the JVT token, let me see who is the user who is doing this thing. NEAR log, I'm just logging something. These logs can actually be seen on chain as well later on. Just string interpolation, whichever account ID set the message with the set the status with the message, and then I'm just saying my records up there, which is an unordered map, set key will be the account ID, and the value is going to be the message. Everyone is familiar how hash maps work and everything, key value pairs, like simple as that basically. So later on, I can always ask, which we have down here, give me the message, get the status for a specific account ID, right? Simple as that. Another thing that's kind of interesting here for the call method that we need to talk about is the fact that, I'm talking a lot.
Some water.
Yes.
Here.
Yes, thank you. I do want some water. So, oh no, I'm good with water. No alcohol for me, you know. I'm trying to be on my best behavior. So on the call method, so what we can see here, this line is actually important. This dot record is set, account ID and message. I'm actually saving something to this collection. So if I'm saving something to the collection, I'm actually saving something on chain. So I have to pay something, right? Pay the piper. So we cannot just save stuff and just like, I'm good, just write it down. So I have to pay something. So the main question is, who is paying in this case? So in this case, who's going to pay for this storage that we will spend by writing this message? Our contract. So if my contract was located at messageboard.near, that's going to be the location of it. Let's say that that's the URL of the contract of our server. So my contract itself is going to pay for the storage. So I'm going to have some NEAR tokens on that account so I can pay for the storage. And this is not a good contract. This is not something that you would want to do. Why? Well, if you're actually sending this out to millions of people to use and so on, because what's going to happen is I'm going to come in, I'm going to write the message. You're going to come in, you're going to write the message. 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 And who is paying for all of that storage? Well, I am, because it's my smart contract, and my smart contract is paying for it. So I don't really want that, right? So what I would like to do is, a proper way to do this would be for me to say, if you want to write a status message to my contract, pay for it. Pay for the storage. I want you to pay for the storage that you're going to spend, right? In that case, we would add here in the annotation that this is a payable function. So if I mark this as a payable function, if Alen tries to call this method and set a status message for his wallet, this thing is going to say, yes, you can do that, but come and pay. So I'm going to need you to pay something. Now, this is kind of like a more complex part. I'm just going to mention it. I'm not really going to go deep into it because it's a really more advanced topic, and I just want to get an idea of how these smart contracts work. So the interesting part here is, how do I know how much does he need to pay to save this message? Well, in a proper smart contract, I can actually maybe take a look at some of my Rust smart contracts and actually show you the code in Rust. What I would do is, at this point in time, before writing anything, I would ask my smart contract, what's your storage right now? How much storage are you taking up on this chain? I would get the information. Then what I would do is, I would set and write this to the contract and ask the contract again, how much storage are you taking up now? Then I would take the difference between the initial storage and the new storage, right? And I would check how much storage, what's the difference in storage, and how much NEAR tokens does Alen need to pay to actually pay for the storage. Then I would check, did Alen actually give me and send me enough tokens? If he did not, I would just revert the changes and tell Alen, tutu, get some money and come back. No pesos, no playing, right? So that's a more complicated thing. We have a very simple contract, as I said here. Contract is going to pay for everything, basically. View, it's a GET request. You're just reading. You don't have to pay anything. You can just read. And you can read as much as you want. The only difference is this part here. OK, so we had get all statuses, so I'm iterating over this thing. That's why it's an ordered map. Yeah, so basically records.keys to array, and then I'm just taking out the data based on keys, putting it all in a simple array list and returning the results. Very, very simple, nothing crazy there. The only thing that we have to worry here when it comes to NEAR is the fact that if your collection gets to a certain point where you have millions, well, I think around 300K entries or something like that, and you try to do this, it's not going to let you do this. It's going to start giving you an error message, something like gas exceeded, etc. Like as if like you did not pay enough to do this thing, which is a very confusing message, but really doesn't have anything to do with you paying anything. It just has to do with the fact that the operation that you're trying to do, iterating over so many elements, is actually just too expensive for the virtual machine. Because in the background, the virtual machine is actually doing this work, right? And the virtual machine can say, OK, this is just too much work for me. You have to rethink your approach, rethink your code base, and implement this in a different way. So a proper way for me to implement this would actually be to implement a pagination. A simple pagination would resolve that issue. As long as you limit the person to not be able to come in and say, oh, I want to, for this page, give me page 1, give me 100,000 results. Limit them to 10, 15, 20, and then just let them paginate. It is what it is. So yeah, this is, as I said, very simple smart contract. A couple of methods from get all statuses, get status, and set status. Nothing too crazy here. You can also use inheritance. It's possible to use inheritance here. You could have other classes that also have this NEAR binding annotation. You can extend them, basically inherit from them, and so on, and it would work. Now, let me just show you. Koja adresa? We are devs, jel?
We are devs.
If I go to the Explorer, NEAR blocks, and I will, big enough. We are, we are devs.near, I think that's the name. Yeah. So look, this is an account. You all created these NEAR accounts as well. So vrdevs.near is also an account. It's a wallet, let's say. It's an account on NEAR network. Right now, this account has balance of 5 NEAR, which is, well, $18. And basically, we can see that there are some transactions here, some that failed and some that succeeded. And you can see the method that's being called is set status, set status, set status, set status. There's a lot of set statuses here. I think that's actually the only one that's actually doing something on chain. We also had a deploy contract method when the contract was being deployed, and a transfer of tokens, basically. Like contract was, well, this failed, but OK. So let me just show you this. Back, we are devs. OK. Well, we just refresh. Let me take a look at this one. this was an action that was made on the smart contract that we looked at. And refresh does everything. We can see that this transaction was a success. This is the account that did this. You know, try it NEAR. There was a transaction fee of 0.00125 NEAR that was paid by our contract. We can see the execution plan. If hold up, no, go away. We can see the block time. God, no. Okay. I will stop clicking stuff. Just load and I'm going to be happy. Refresh. I just need to show you one more thing here, and that's basically okay. So we can block time is not loaded. We can see that this account did a transaction to this account. VRDevs.near is where actually our contract is located, and we can see what happened was that our set status method in the contract was called, and what was sent in it? A JSON with a proper message and a value. This is pretty neat. Good work, team. Another thing that you can see is a log. You know, try with NEAR set status in the message. This is pretty neat. Good work, team. This is exactly what I told my contract to do. Look, set status. It's passing in a JSON which has a property message. I'm deconstructing it. That's exactly it. Set status is the name of the method. Yes, it is. And finding the log is whatever the account ID is. Set status with the message, whatever the message is. And we actually get this log here as well. Does this kind of make sense? How do you feel about this? It's not that bad, right? Well, simple enough. And that's more or less it here. I can additionally maybe show you. Let me just see if. So if I go to the vrdevs.near, it's actually not loading my contract here, which is not good. Yeah, this is very slow today. I don't know what's happening. Okay, but usually if this was not so slow, it's probably loading it. But there would be a tab. Okay, it loaded it. Contract. You can see the contract info and you can see the contract methods. Now look, I can actually see like status message, get all statuses, get status, set status. And I could basically say get all statuses, query, and look, I'm actually getting a response because I'm just reading from the chain. I'm just asking, give me all of the statuses that you saved, like throughout all of the time, right? We don't have that many here, so it's not going to fail. If I had hundreds of thousands here, it would have failed. It would tell me like, no, you're crazy. It's too much work for me. Just do the pagination and piss off. I could also say get status. I could add an argument here and say account ID is of type string and put in, like, I think I can do this, account ID of type string, igris.near, for example, and I can say a query, give me, you see, I can ask him and tell him like, this is a GET request where we are passing in an account ID, so I'm basically asking, get me the status message for this account ID. Very simple. So if you just think of it as a backend, as a REST API, it's very simple to build stuff. Still not crazy. And now you can take over and do the boss part.
So thank you, Andrej.
Oh, no problem.
So this was the first part. This was the explaining of the backend and how it's working in the background. So now what I would like to show you and maybe interact with you is that you create your own component that actually connects to this smart contract and publish it on Boss, so like a decentralized front end, and then push a message or a wish for the end of this workshop. So first of all, to get the code, you would need to go.
Huh?
Kod share.
Kod share. Koda share.
To je na...
Evo, ne, ovo je screen recording, stani. Veliki problemi, prijatelj.
Super.
Ne, ovo nije dobro. Ne znam, prijatelj.
Ok, Telegram.
Telegram. Telegram.
Evo ga. Ok.
I možeš na NEAR Balkans kod mene ovdje slobodno. A imali smo ga ovdje.
Kako? Aha.
Jesam li ulogiran?
Je.
Jesam, dobro.
Ok, znači prvo, ono što bi zamolio je da otiđete na
English.
Coacher.
To go to English.
Aha, to go to English, sorry. So,
Poveća maksimum ekran samo,
yeah, wait.
ali full screen.
Yeah. Just a second. How do I...
A kopiraj kod, stavi ga tamo. URL, da.
Just a second. So I will try to do this like this.
Dva puta samo gore, bro.
Do you all see this from all the way from the back? The link?
Awesome.
Yes. Just please copy, do not cut.
Yeah, please.
Copy, not cut.
Okay, somebody cut. Okay. So now let's first start with the code, and then I'm going to show you the documentation and what is available, what is not. So. Okay, so to publish the code, to create the decentralized frontend on BOSS, you need to go to near.org webpage. Then after you get there, you will need to log in. No, wait. You will need to log in. Let's do it.
So
like
near.org.
Near.org. And then you will see, just a second, sign in button. Go there, continue with wallet, and now you select my NEAR wallet. Is everybody following? Ah, okay.
I have problem with pasting. It's changing URL to lowercase.
What do you mean?
Coacher.
On Coacher?
Yeah.
Napravi novi Coacher.
Aha.
Ali napravi ga ovako. Čekaj, imaš kod, jel tako? Kod share.io/near.
Može se koristiti.
Aha. Dobro.
Jer možeš tako i samo... Try this link now. Kopiraj samo kod. /near. Yeah.
Aha.
So there are no issues with the small capital case and lowercase letters.
So kod za...
Samo tamo je za lijepo isto.
Može. Sure.
Yep.
Here you go. Okay, and then just a second, and then so everybody went here, right? Oops, what the? Okay, this is not my computer. Near.org. This is the URL for the page. Okay, so no. Yeah, here it is.
Where we can find the name wallet? Is that account or?
That's your...
I'm going to get to that now. So did you get to this page? So okay, so go.
Napravi X opet počne login proces.
Yeah, so this is the URL of the page that you need to visit now. Then when you get there, there is a login button.
Go back and go again to the sign login, just so everybody sees.
Sign in here. Did he? Yeah. Is okay. Sign in. Continue with wallet, and then you have my NEAR wallet.
Just one second. So the first option you will get is NEAR wallet, which was before the default wallet for the NEAR ecosystem. But to be honest, it's a bit shitty, so we are discontinuing it. That's why Alen is opening on my NEAR wallet and going on my NEAR wallet, just so it doesn't confuse you because it's on the first place.
Yeah.
Choose the my NEAR wallet.
Okay, so my NEAR wallet, and now enter the password that you entered when you were creating the wallet.
And then we can steal all of your funds.
I don't remember mine. Just a second.
Dobro,
Where is forgot passport part?
Yes. Sorry, what? I thought that I forgot mine. Okay, so if you were,
Anybody has a question? Are you able to?
did you get to this page?
Yep.
Okay, so if you logged in with your wallet, then it should be here, right? Then just click next. Okay, so this is something cool about NEAR. So each time you log in somewhere with your NEAR wallet, it generates the new function key. Function key is the key, like a key pair of private and public key that we were discussing earlier, that doesn't let the application control your funds. So here it says just view the address of your permitted account, view the balance, and call methods. So there is no transaction or I don't know or transaction or changing or swapping the tokens and stuff like that. So this is really cool because this is additional security, and each time you log in into application, you get a new function key, and so it cannot be misused and used multiple times. So just click connect. One more thing. Network fee allowance is 0.25 NEAR. Which means actually that if the smart contract is going to take, I don't know, for gas fee that Andrej talked about, when there is no money or you need to interact with smart contract, if it's under 0.25 NEAR, then it's not going to ask you for the permission. If it's over 0.25 NEAR, then it's going to ask you for permission. This is also in settings that can be changed depending on the contract and the application itself. Okay, so when you click connect, you get to the initial page, and now what we need to do here, we need to agree to terms of service and privacy policy, and this is going to be your first transaction on blockchain. So when you click continue,
It might take a while for this to pop up.
yeah.
It can be buggy.
When you click continue, you wait a little. Okay, so this is the transaction that we're going to do. So Alen M.NEAR is going to accept privacy policy and terms and conditions, which means that this is like a check mark, but on smart contract on blockchain. So when you do save data, you're going to be redirected to the wallet page to authorize the transaction. So now you do your password, and here it is. So this transaction costs 0.02 NEAR, which is $0.07, and it is going from Alen M. Estimated fee is less than 0.0000. When you click approve, you have signed terms and conditions for NEAR.org. Okay, is everybody on this page now? Yes. Anybody have questions? Yes.
Yeah, I didn't get terms and conditions. It didn't pop up at all.
But you enter the page.
Mislim da refresh, možda refresh.
I'm logged in, but
Okay, we'll wait a little.
She's logged in, but it wasn't a pop-up.
Okay, moving on. You save some money. Okay, so now to develop the components and the application, front-end application, we go to develop and sandbox. And here you have this option to actually select the guided tutorial and stuff and go step by step. But what we want to do, we already have completed components. So what we're going to do, we're going to create a new component. So click on create new component. And here you have the EDA for writing the decentralized frontend on NEAR/boss. So here you can paste the code that you got from CodeShare, which is somewhere here. Just a second. So let me try to get it. Fuck. Yeah. Okay. Oops. So it's here. So just do like this, and we are going to remove this. Okay. So first, did everybody do that? Is everybody here on the same page?
On the previous page, I cannot get there.
Uh-huh. Yeah, give me a second.
Što je?
Ajde, budemo. Sam da idemo na brzinu. Okay.
When I approved it.
Okay. Awesome. Develop.
Okay.
Develop. Sandbox. Create new component.
Okay.
That's it. No problem. Yeah. So everybody else got to this step? Okay, so what I had in mind, so everybody's going to create their own component. I'm going to explain the code, and then you can style it and customize it per your preference. And of course, leave the message at the end. So first, we have account ID, which is your wallet ID, which these props and context. So props.
For the people in the back.
But they have the same code. Okay, so props means that, so this is modular. Components are modular, which means that you can, I'm going to show you at the end. So we are going to call this component in the widget, in the component of egress.near of Andrej, that actually did the component that wraps Daisy UI wrapper, which means that we will be able to use the Tailwind and classes and everything that is here, for example. So starting from here, if you want, for example, in the next time you create a component, you want to have that component inside of this component, which means that you can send the prop of the account ID to that component so that it can be used. Otherwise, use context. Context are static available variables that are available in the blockchain BOS itself. Then we have contract ID, which is the contract ID that Andrej was explaining. It is wearedevs.near, and this is the ID of the contract. So then we have state. State, when we are initializing the state, we want to have messages and we want to have states. So this is just the init of the state, similar like in React. Then, just a second. Can I move it up? No, I cannot. Then we have get messages. So with these get messages, this is similar to the get method of the smart contract that Andrej was explaining. So what we are saying is use near object and then view method, which is actually, I can show it to you. So get status, I think it's here. Yeah, no, it's get all statuses. So we have view method here and function get all statuses, which means that we are going to call near view method with contract ID of wearedevs.near. Function get all statuses, we are not going to send any data to it. And then after we get the response from the smart contract, we are going to update the state with the messages that we got. After that, we have post message, which is actually call method. So if we don't have an account, which means that the user is not logged in, we cannot do it because we don't know who posted it. Then we have stay status equals null or stay status equals 0, which means that we are going to return if status is 0 or status is empty. And then we are calling the call method, which is here. Contract ID set status. So if we go here, this is that method. So we are calling call method, and we are setting the status, sending this object that Andrej explained earlier. So this is it. And after that, we want to update the state. So what we are doing, we are calling the get messages. Immediately when the component is initialized, we are also calling get messages to get the latest status of the message board. After that is just content, so it's HTML. We have the classes, the CSS classes, everything is nested, everything is supported, and yeah. we have this kind of messages, and you know, this is the same syntax that you have in JavaScript and in React. So yeah, that's actually normal. And we have buttons on click. And we are iterating here from messages to actually show the messages how it looks. One more thing I wanted to show you is actually what we are doing. So BOSS actually in general supports style components. But since we don't want to work only with style components, we wanted to work with Daisy UI. We wanted to, Andrej created this widget, this component, that actually accepts this, as a children, accepts this content of here and sends, and the theme of Daisy UI. So there is also, you can select, just a second, here it is. You can select any of those components, any of those themes, and it's going to, you know, change the layout. Okay, so now when we did the component, we wanted to see how it looks, how to see it, component preview. And here it is. So this is our component. Yeah, just a second. Maybe I can now zoom out. Ah, awesome. Okay, so if you want, customize it by using different themes, and yeah, by actually using different theme, so that you can see how it is done and how it is played out. And then once you are done, to publish the component, first, is everybody following?
Where can we preview components?
This is the tab here, component preview. Yeah. Okay. Everything okay? Awesome. So now when you want to publish the components to be on the blockchain and to be findable here, we need to add the title, icon if you want, description, tags, and maybe the website for the reference. So for the title, can you just please enter Quantox and then workshop, for example. Workshop, my first component. And then for the tags, we have. Yeah, with space. Yeah, yes. Quantox. And then we have, I don't know, blockchain and workshop.
You can put the Quantox as tag.
What, sorry?
Quantox as tag as well.
Quantox.
Yeah, I did.
Ah.
You are the one that need to go to the
Yeah. Yes, I don't really see much from here.
Okay. When you're done, when you're ready, so you can always, for example, if I want to change from dark to, what was the?
Make it Christmassy.
Christmassy. Winter, oh, here you go, winter. You go to component preview, you see it changed the overall look and feel of the component. Okay, so when you customize it, when you're done with the customization itself, you go to publish. And here you can see, again, the transaction that we're going to do. So we are doing untitled 0 component. This is the content of the component. So this is going to be transferred to us to bytecode and then placed on the smart contract. And then name, tags, and everything else that you needed to that you wanted to do. When you save data, and then
What is enough to put the metadata? Just title and tags?
Yeah. So yeah, exactly. Yeah, for now, yeah. But if you want to do it like a more detailed, you can also do it more detailed. So you can add the image, and you can. That's actually what you can do, I think.
Okay. After that, we just need to publish.
Yes. Okay. Since we have a reasonable amount of code, this is the price that we're going to pay for publishing it online on blockchain. Okay. And I think it's done. So now when we go here you go. Quantox, here it is. So now when you click on it, for example, this is mine, you can preview it here. You can see the code, you can fork it, you can see the source, you can share it, you can do anything with it. But the best thing is you can leave a message. And then when you do this, it's
Every time like this, you should confirm transaction.
yes.
Each transaction, like do we add the favorites, the likes, on posts?
Yes, because everything is on blockchain. Because everything is going to, so it's nobody will be able to say that you didn't like it or that you didn't comment on it. So everything is written in smart contract in blockchain. And then you confirm. I know. This is why there is also this allowance that can be measured later, you know, that can be customized. And when you approve it, you will be able to get, I think it's here. Hello from the workshop. Here it is. This is it. Yeah. Okay. So for the detailed documentation and everything, you can go to the.
I have black text color on black background.
Same. Okay.
Come to the dark side. Huh?
Yeah. So if you go to this URL, learn docs.near.org. So here, where was it? I think it was.
Where can we see that message? We click button.
So
Same transaction, but where can we see history?
when you go to, so here, for example, this is, yeah, and then preview, it's going to load, initialize the method, and then, for example, my message was here at the end. Yeah, awesome. Okay, so for the detailed documentation and what is available, what is not, you can go to docs.near.org, boss overview. Here you can see all the intro, all the steps that you need to take so that you can create the component. But the best part is there is also examples and tutorials, but there is component API, which is you have state, which is then explain the state init, state update functions that we were going through before. And then we also have NEAR, which is NEAR block, NEAR call, NEAR view. This is calling of the smart contract methods and types of them, and the block of which block how to use it, optimistic or final. Also we have fetch, so this here, and at the end you have examples and tutorials, which means that you can actually see and check out what is available, what is not, and how it is available and why it is not available. And that's actually it for the components. Do you have any questions? Or is everything clear? Oh, good. Okay, then I think that's it.
What happens if we run out of NEAR tokens? Then we cannot do anything?
Yeah, but you can still view. So you cannot change the smart contract and update it, but you can view all of that is done until then. So it's like get and read, and update, delete, and insert is not available if you don't have the finance, if you don't have the tokens. Yeah.
One question. Whenever we edit something in the code and want to publish it, we pay just for that change, or
The whole change. The whole. Yeah, because you're actually creating new component. Yeah.
And the history is preserved, you said.
I think.
Previous versions.
Yes. It should be here. Here it is.
So you cannot delete that? Or
No, this is because it's on the smart contract. Yeah.
that's what I wanted to ask. So when you have a blockchain, you actually cannot remove data. You can only add to it or something like that.
Yes, at some point, yeah. But the thing is, with smart contracts, you can delete it, but it's going to stay in the history. Yeah. So, but from that point on, the smart contract is not counting on that data.
But it's still taking some size or something.
Yes. After you do this, it's like the action. Yeah.
It's not like database where you can remove.
So, yeah. So if you ask about the data from the smart contract, yes, we can delete the data. If I were to delete, if we have 10 status messages there, and I go and delete them, I actually remove them from the collection. The money that we spent for storage is going to be returned. We're going to get like the money back, but partially. We're not going to get full refund. We'll get some money back. Now, if we want to return the money to the user, we have to implement it on our own, because money by default, any storage that you free up in a contract, is just going to be returned to the contract itself. So you free up the space, you get back some tokens. Yeah.
But you still have history of that changes.
Yes, everything. Yes, everything stays on chain. Everything stays as a transaction on chain. Even if we.
Blockchain only can grow, cannot get.
No, it's not going to get smaller. You cannot remove blocks.
Yeah.
Exactly.
Yeah.
No.
Okay.
So in the context, if you have like that application which is actually charging for every post, I presume that there is a way to share your component to other users that can actually use it, right?
Yeah.
Yes.
Let's say that I want to allow a user to just send for free their,
Then
they're
this
just going to post on my account, but I want to actually distribute my component to someone, to a third party, which is going to actually pay me for use of the component.
Then
Not too much. No. So the only way to achieve something like that is because anyone can fork your components, so I could easily change the code of it. The only way to achieve that behavior is to have your component doing something with the smart contract, right? And then implementing that logic where you take a certain fee or a tax on every transaction within the smart contract. So in the UI part here, we cannot implement this because.
So is there actually a way where we can actually avoid paying directly by wallet? It's just going to be connected to someone else's wallet? Or
Yes. We can do sponsor transactions. Like this is the sponsor transactions could work there. So basically, I could say that my smart contract is going to take care of all of the expenses, and the user
this is what I wanted to mention. Yeah.
So this is also something that you can do, like a mixture of Web2, Web3 thing. For example, we build projects like that. So you come in, you scan a QR code, you get an NFT, but you don't have to pay for anything. Like we cover all of the expenses, you just get the NFT in the end.
Yeah.
So it's possible.
Okay. Any more questions? Okay. So for the end, we wanted to give you the first NFT, and that's here somewhere. So this is it, right? I think that he said. That's it. Sorry, it was the other link.
Oh yes, that's a big QR code.
Yeah. This is the certificate that you managed to finish the workshop successfully. Yes. And now for the final words.
David, jel se može dobro... Daj refresh.
A ne mogu...
Refresh slide samo.
Čekaj.
Znači, izađi i samo refresh prezentaciju.
Dobro.
Jer je sad malo pomaknuto gore u sredinu.
Pomaknuto.
Samo refresh još jednom.
Ne, pomaknuto tako nego je... Može se?
Može se skenirati. I od ozade, jel se može? Super, da vam
Hoćemo i link dati na coacheru.
Daćemo, znači šta je sad idući korak u principu, sad kad je ovo sve tu završeno, istestirano i ostalo, ići će jedan follow-up mail gdje ćete dobiti guidebook sa resursima, sa svime, doći će vam još jednom link i QR kod, tako da ako slučajno je nešto negdje zapelo, uvijek možete i naknadno i to je u principu to.
Da. Eto, hvala vam puno na pozornosti i pažnji i nadam se da vam je bilo dobro.
Hvala.
Bravo.